Before we introduce the last big idea that we're going to cover this year, let's do a little bit of review. If I asked you to solve this particular quadratic equation here, 12x squared plus 15x equals 0, the first thing I've been talking about, you should always be asking yourself is, can we factor out a GCF? That's your one hint here. So what I'd like you to do is see if you can't factor out this binomial using the GCF. Hit pause right now, see if you can't come up with the factored version of that binomial. As I'm looking at this binomial here, this is not a trinomial situation, obviously, so this is one where I'm going to look for a GCF. And if I'm looking at the 12x squared plus 15x, I'm going to look and see that both 12 and 15 are both divisible by 3, and they both have at least one x. So 3x must have been distributed over something to figure out, to get that binomial. If we divide both of these by 3x, we'll get what's inside the parentheses. And that gives us 4x, 12x squared divided by 3x. 12 divided by 3 is 4. One of the x's cancels out. And then 15x divided by 3x just gives us 5. Since we know one of them, or both of them, must be 0, since the product of them is 0, that's the zero product property, either 3x is equal to 0, or 4x plus 5 is equal to 0. So if you were to solve that using the zero product property, this one's easy. And this one you might have been able to see even before you did all the factoring. What's that? X could equal 0. X is a solution, or 0 is a solution to that, as is negative 5/4. That one's going to be a little trickier to check, but if you did plug it in, it would work. So one way to solve a quadratic is to see if you can't factor out a GCF and then apply the zero product property. This is not a case here in this one that we could do that. We don't have a GCF besides 1 in this case, so we're going to see if we can't factor this into a binomial, or into a pair of binomials that multiply together to give you x squared plus 16x minus 17. This is what we've been doing a lot of as of late, so hit pause on this recording, see if you can't factor this trinomial into the product of two binomials. Well, since we know GCF isn't an option, we should look at it as seeing if we can get it to be the factor of binomials. I like it when there's just the x squared and not a coefficient other than 1 in front of that, so because that's going to make this x and this x. I'm going to look at this operation to tell me that both of these are going to be different. Obviously, I'm multiplying something together to get a negative, so it's got to be a positive and a negative, which translates to addition and subtraction. So now I'm looking for the factors of 17, or negative 17, that are 1 apart. And fortunately, 17 is prime, so I know that 17 has to be the bigger one because this is positive. So 17 and 1 are my binomials that gets factored into. And you could easily check that and see that it does work out. But now that we know that x squared plus 16x minus 17 is equal to 0, this is equal to 0, meaning either x plus 17 is the one that's equal to 0, or x minus 1 is equal to 0. Subtract 17, subtract 17. So x is either going to be negative 17, not 7, or x is going to equal positive 1 by adding 1 to both sides. That's what we've been doing right along. We've been doing a lot of this factoring the last little bit. But as soon as we throw that equals 0, that brings in the zero product property. You can probably guess where I'm going next with the next problem. And that's going to be one of these here. So this is just the same situation. We've got a trinomial that doesn't have a GCF besides 1, so we know we can't factor out a GCF. We're going to try to get it into two binomials. And to do that, we have to do this little trick here where we take the factors of A and factors of C and try to get them, when we multiply the outside and add it to the product of the inside factors, see if we can't get it to equal -1. No, I'm sorry, -2. So take a minute or two right now, see if you can't figure out what the factors would be that would give us -2. Fortunately here, both A and C are prime, so we don't have a ton of choices by way of factors, but this one being negative does mean we have to take that into account. I'm going to start with 1 times 3, and there's really not a bad way to start that there, but we need this over here to get to -2. Well, if I put 5 then 1, at some point I'm going to be multiplying that 5 by 3. And I don't want to do that because that's going to make a number that's too big. We're not going to be able to work with that. So I know that I have to do this. I know I have to make it 1 times 5. Now I just have to ask myself, which one's the negative? Is the bigger number negative or is the smaller number negative? Well, since this is negative, it means I have to go with the bigger one here. And when I do 1 times -5 and add to it 3 times 1, I get -2. So I'm in the right place. So when we build our binomials from here, we take the first numbers and build the first binomial. So that's 1x plus 1. And then we take the second numbers and make the second binomials, and that's 3x minus 5. And just like we did before, since we know this equals 0, we're going to set both of these equal to 0. I don't know what I did there. X plus 1 is going to equal 0, or 3x minus 5 is going to equal 0. Well, this one's the easy one, because it's kind of like what we've been doing before with the trinomials. Here we have to do slightly more math, and I mean slightly. So x is either going to equal -1 or +5/3. So in all these cases, we've been able to factor these. We've been able to utilize the zero product property. And we factor these quadratics such that we can get them to get to an answer using the zero product property. If we look at this one, x squared minus 8x plus 10 is equal to 0. That one doesn't have a greatest common factor besides 1, so we know that can't be it. We're not going to use our GCF. Then we're going to look at, okay, well, can we turn it into binomials? Can't do that either, because the factors of 10 are 2 times 5 or 1 times 10. Both of those would give us 10, but 2 plus 5 gives us 7. 1 plus 10 gives us 11. And yes, they'd be negative because of this, but it doesn't really matter because it is not going to give us the number that we're looking for. This is a situation where we don't have factoring available to us as a tool to help us. What we do have is what's called the quadratic function, or the quadratic equation rather. And basically what it is it's a clunky looking thing, but it really isn't all that bad. For any quadratic function, ax squared plus bx plus c equaling 0, You can find the values, you can find the solutions using that equation there. The opposite of b, and that's important, the opposite of b plus or minus b squared minus 4ac all over 2a. So let's just walk through this one real quick, and then hopefully by this time I'll be able to, I'm going to move this over though because it's almost off the screen. I can see that. There you go. All right. First things first, I'm going to look at my trinomial and say, all right, what are my a, my b, and my c values? The a is the coefficient of x squared. There is none, so it's 1. The b coefficient is the coefficient of the x term. That's negative 8. And then the constant, or the c, is 10. This is negative because it's subtraction. This is saying it's the opposite of whatever b is. So as I start plugging this in, it's going to be the opposite of b, which makes it positive. Plus or minus, and we'll talk about how to deal with that later, negative 8 squared minus 4 times 1 times 10. All I'm doing is taking out those variables, a, b, and c, and replacing them with the numbers that we have, all time 2 times 1. Right? If I look at this right here, if I look at what's under the radical sign, this is called the discriminant. We're going to talk more about that later. But that, if I do negative 8 squared, that gives me 64. And then I subtract 4 times 1 times 10, which is 40. I'm going to get 8 plus or minus the square root of 24. And I don't know why that just changed. That's a little weird. I did not do that. All over 2. So if we were to do that, when we were to do that out, remember, we've got a plus or minus here. We're coming up with 2 different numbers. We're doing 8 plus the square root of 24 divided by 2. And I just got to do that out real quick. 8 times square root, 8 times square root of 24, all divided by 2. No. 8 plus, sorry. If I actually plug it into the calculator correctly, I get about 6.45. And if I do the same thing with the subtraction, I get about 1.55. If you're at a point where you have to use the quadratic formula, it's more than likely that you're going to get some ugly looking numbers. Not ugly, but numbers that aren't nice, neat whole numbers. The nice thing about the quadratic formula is it'll work for just about any of them. So if you want to just remember this and use it in all cases, then you don't have to worry about trying to remember the tricks that we were doing before. But if you go through this process and you get nice, neat whole numbers, well, you probably could have done it a different way. But that's fine. You still have the answers. So that's how we use the quadratic formula. X is equal to the opposite of b plus minus the square root of b squared minus 4ac all over 2a. I'm never going to make you, you'll always be able to write that down and have that somewhere. That will give you the solutions to x to the quadratic function, to a quadratic function if it exists, right? This is the introduction to our last kind of idea here that we're going to probably be tackling with quadratics. We'll get plenty of practice with this in class when I'm back with you, which hopefully won't be very long at all. So thank you for paying attention to this. Please let me know if you have any questions. I hope this helped.